wabarakatuh. My name is Abdul Hazim bin Nasruddin. So I will present regarding the earthwork design. So for the introduction, earthwork are referred to the procedures where the surface of the earth is excavated, transported, and also compacted at another location. So it's generally the most of earthwork are generated by the process of cut and fill. So it is important to consider the type of fill material as well as the physical characteristic of it. So the amount of soil volumes for the cut and fill must be calculated in order for us to know how much the soil to be cut and also to be. So the next part is the scope of work. There are 4 scope of work, which is site clearing, grubbing, stripping tool, and also disposal. So for site clearing, the land clearing makes way for new subdivisions, construction site, or commercial earthworks. For grubbing is the vegetation and surface debris are removed with clearing once a site has been inspected and any necessary demo work has been completed. So next for the disposal is the process of leveling. Next is the stripping tool. Stripping tool is the process of leveling all the existing grades in the space. And the last part is the disposal, which is that all items originating from site clearing, grubbing, and stripping topsoil must be removed and disposed. So next is the earthwork equipment. There are backhoe, dozer, shovel, jumper, and also roller. So the method that we use to calculate the cut and fill is the grid line method. So the grid line method is used to determine the current and projected ground levels for each grid node, and then calculate the necessary cut or fill. Once the cut or fill depth has been determined, multiply the result by the grid cell area. So we must do this for every grid square, then we add the volumes to get the project's overall cut and fill. So this is our grid line layout. So as you can see, we do the grid line by drawing a tables of 9 times 5. So we have 9 times 5 boxes. So and then as we can see, our proposed level is 48.5, and it's conclude the contour. So this is our grid line calculation. As you can see, on the first grid we have to fill with negative of 250 volumes. So the second grid of 2, 3, and AB we have also to fill 197.5 volume. So and most of the grid line, most of the process is fill, but there are also cut, which is as we can see on the grid line of 910 and 910 EF. We have to cut with the amount volume of 155.5 cubic per meter. So this is the earthwork layout plan. So as you can see, we have the temporary culvert here, we have the front gate, temporary drainage, the wash through, signboard, temporary culvert, and also the temporary silt trap. So the front gate and the buildings is quite far, but it's because I follow the road design drawing. So this is our earthwork layout plan that will be proposed. So that's all for the earthwork design. Thank you.
Assalamualaikum, my name is Muhammad Samanhai bin Abu Qasim. My metric number is AF190092 and I will present about the drainage system. First introduction, the main goal of a road drainage system is to effectively remove water from the road and its surroundings. It consists of 2 components, dewatering, which focuses on eliminating precipitation road from the road's surface, and drainage, which involve using various infrastructure elements to keep the road structure dry. For the process drainage design, first select design ARI, second discretize subcatchment, third estimate time of concentration, fourth determine average rainfall intensity, 5 estimate runoff coefficient, 6 calculate average runoff coefficient, and lastly calculate peak flow rate for the subcatchment. For the channel size, At the left side is the standard size U-drains and U-drains with dry weather flow. For the project we use the standard size U-drains dimension and properties at the table below. Okay, for the drainage layout plan, there is 6 nodes, which is this is the sum pit 1, sum pit 2, sum pit 3, 4, 5, and 6. The longest link is link 5, which is 42.67 meter, and the shortest is the link 4, which is 27.29 meter. For the channel gradient is 300, and the ground level for the project is 48.5 meter, and the discharge is okay because of the capacity is bigger than the discharge, which is 0.309 for capacity, and the discharge is 0.0103.
Assalamualaikum, my name is Muhammad Ali Rizwan. I will be presenting about the infrastructure which is design. So the design that our follow is according to the Jabatan Kerja Raya JKR standard, which is from Arahan Teknik Jalan 585 manual on pavement design and Arahan Teknik Jalan 886 a guide on geometric design of roads. Existing road. Existing road with the width of 7.5 meter was constructed nearby the project site. There are also two junctions going in or out from the main road, which will be convenient to provide an excellent traffic flow for the building whether it is in construction phase or to be utilized by the occupants. So next, proposed road. The proposed road will be a one-way road which have a 5 meter of width. There are one entrance and one exit. Figure below will visualize the proposed road into the premise area. Design properties. Class of road is R2. Initial daily traffic volume or ADT is 60. Design life of road 10 years. Percentage of commercial vehicles PCV 15%. Annual growth rate 7%. Equivalent factor 1.2. Subgrade California bearing ratio or CBR 5%. And the terrain is flat. Design calculation result. So initial annual commercial for one way VO we got 1642.5 vehicle per year, and the VC we get 0.23 power of 5. The total equivalent standard axle ESA 0.23 power of 5. The maximum hourly traffic volume is 1113.6 vehicles per peak per hour. Assuming hourly capacity is 10% of daily capacity, so it is 11,136 vehicles per lane per day. And total daily one-way traffic flow of both non-commercial and commercial vehicle is 59 vehicles per day per lane, and the thickness is 13.8 centimeters. So this is the road cross section, and this is the road design drawing. Thank you very much.
Assalamualaikum, my name is Azaria Patricia binti Muhammad Hamdan, and I will be explaining about sewerage design for Group 1. For proposed sewerage layout plan, we have 5 manhole including existing manhole and 4 proposed manhole. For the showroom building area, total PE will be carried by unit PE times by area, so the total population for showroom building area for 6 floor is 59.28, and for the average flow rate is 1.54 times 10 negative 4. For peak flow factor is 6.41, and for peak flow cubic is peak flow factor times by average flow, which is 9.8714 exponent negative 4. For design of pipe velocity and capacity. The dry weather flow is PE times by 0.275 meter cube per day, which is 1.887 exponent negative 4 meter cube per second. The proposed gradient is 1 over 200. So for the calculation of velocity using for many formula, the calculated velocity is between the permitted range 0.45 to 4.0 meter per second. So the cross section is satisfied. So the area is 0.04 meter square and the velocity is 3.18 meter per second. So the Q calculated is 127.2 liter per second. For the pipeline capacity, 127.2 liter per second is larger than the peak flow rate capacity, which is 9.8714 exponent negative 4 meter cube per second. So which is the pipeline capacity is okay. For this proposed layout plan, we have 5 manhole including the manhole existing. So the 4 proposed manhole is manhole 1, manhole 2, manhole 3 and manhole 4. From the study, this study states that manhole depth should not exceed 6.5 meter. As you can see from the Excel calculation for our group, our manhole depth is in range 1.2 meter to 3 meters. So our manhole depth is allowable for the calculation, and the depth is shows okay, which is acceptable. The next part is water reticulation design. And this is our proposed water reticulation layout plan for our group project. For this showroom building, the daily water demand is 3.811 liter per second, and the total water demand is peak water demand plus fire flow demand, which is 54.5275 liter per second. As for peak water demand, it is divided by nodes. So we have 4 nodes for our layout plan, and the average flow rate for node 1 and node 4 is 3.811, and the peak flow rate in liter per second for node 1 and node 4 is 9.5275 liter per second. For the head loss on pipe, we have 3 pipes for this layout, which is 1 to 2, 2 to 3 and 3 to 4. For the head loss due to surface resistance, for pipe 1 to 2 we have 0.028 meter, for 2 to 3 we have 0.349 meter, and for the pipe of 3 to 4 we have 0.022 meter. For the Reynolds number for these 3 pipe is the same, which is 274.9, which is greater than 4000, and then the friction coefficient for this pipe is also the same, which is 0.014, and for the head loss due to minor loss is the same too, which is 0.37 meter. As for the head loss for pipe 1 to 2 is 0.398, head loss for pipe 2 to 3 is 0.719, and the head loss for pipe 3 to 4 is 0.392. As for water tank design, we will be using the HDPE tank, which is the HDPE TH3000, and the capacity is 3292.7 gram for 1 unit. The nominal size is 4000 times 2000 times 4000, and the TWL is 67.75 meter and BWL is 65.75 meter. And this is the detailing of water tank for our group project.